Welcome back, STEM students, to Mumpaisan's online classroom video lecture. So after discussing about horizontal uniformly accelerated motion, we're going to proceed to vertical uniformly accelerated motion. So in horizontal UAM, that's basically movement along the x-axis that is having a non-changing acceleration, which means it's constant. But the value of acceleration is not zero, non-zero, no? Kaya siya uniformly accelerated and not uniform speed, okay? So now we're going to proceed to, again nga, vertical uniformly accelerated motion. And the other term used for vertical uniformly accelerated motion is free fall, okay? So objectives are the following, same objectives as we have for uh, the previous one. So yung UAM nga, basically, yung one-dimensional UAM can either be horizontal UAM or free fall. So this video's focus will be free fall. When we say free fall, it's the state of a body that moves freely, kaya nga, free, in any manner in the presence of gravity. And in the presence of gravity, things fall. Kaya siya free fall. Kaya naman siya tinawag din na free because you don't need to do anything for it to fall because gravity uh, does all the work so that the object you let go or freed actually falls towards the ground. Examples of free fall are uh, adventurous uh, ano tawag dito? Adventurous hobbies like skydiving and then the famous falling apple, which they say inspired Isaac Newton. Another thing, when you throw things up, that's also considered free fall because eventually gravity wins over the force that you exert and it will fall again. And it could also be when you drop something from a high place towards a lower space or lower place or towards the ground. Free fall, to get kinematics equations or for to get the equations for free fall, we simply change all the x from HUAM rather, whether variable or subscript into y. Moreover, you change all the a into g, and then the g represents actually the acceleration due to gravity that is equal to negative 9.8 meters per second squared. So basically, we use the same equations, but we use different variables. So here are the free-fall equations. As you may notice, pareho lang talaga siya nung sa HUAM. It's just that here, the subscripts become y, and then the acceleration becomes g. Here are the meaning of each variable. We have delta y, which is the change in position or displacement along the y-axis. The delta y can further be expanded as y minus y naught, which is the difference between the final and initial positions. And then the y is the final position and y naught is the initial position. We also have the velocities, which are the v naught y, initial velocity along the y-axis, the vy, the final velocity along the y-axis, and then the g, the average acceleration along the y-axis, which is also the acceleration due to gravity. And syempre, hindi mawawala ang time o t, which is the time of travel, sometimes called the time of flight. We have the same SI units for the displacements, delta y, y naught, and y, we have meter. For v naught y and vy, we still have meter per second. For the g, since it's our acceleration, it's meter per second squared. And then lastly, the time has the SI unit of second, or s. Now, there are two cases for free fall. Free fall can be dropped or thrown upward. The first case would be the dropped. Nilaglag mo lang, binitawan mo lang. parang ikaw, no, binatawan ka na, char. Yan. Ito yung mga conditions, descriptions for case 1. When you drop an object from a higher place to a lower place, the initial velocity is 0. Okay? While the final velocity is non-zero and negative. Bakit negative? Because when you drop something, the direction would be negative. And whatever the direction that your object is going to, that will be the same direction of your velocity. So since pababa, pag drinap mo, ang velocity niya, syempre, negative. Because, di ba, when the direction is downward, it is associated with the negative sign. Next, the initial position or displacement is 0. So you start, the higher place will be considered as our 0, and then the final position will be negative. Later on, these conventions or these descriptions will be uh, useful when we write the given for our sample problems. The delta y can be expanded into y minus y naught, wherein the delta y, since 0 naman yung initial position niya, the delta y will have the same magnitude as the y, and the delta y will be negative. Okay? Let's have the example so that you would be able to visualize it better. Suppose that a ball is dropped from a tower 70 meters high. How far will the ball have fallen after time is equal to 1 second, 2 seconds, and 3 seconds? Anong given natin? Following are given, don't ever forget the unmentioned given, the g, since this is dropped, g is equal to negative, don't forget then the negative, 9.8 meters per second squared. And don't forget that the times are always positive. Pataas man, pababa, pa kanan, pakaliwa, ang movement ng object natin, time is always positive. Okay? And then, since we have 3 times that we need to identify the displacement of, we use subscripts such as 1, 2, and 3. And then, we know since this is dropped, automatically, the v naught y is equal to 0. So, another purpose of the conditions we have mentioned a while ago or from the previous slide is that from there you would have ideas for the hidden or unmentioned given. Ay, given pala siya dito, but not all the time makikita mo na v naught y is equal to 0 when the object is dropped. So, dapat automatic na siya sa utak mo na. When the object is dropped, the initial velocity is 0. Because syempre, we assume na bago mo yun i-let go, hindi pa naman siya gumagalaw. So, ang initial velocity niya is 0. And then we are looking for the change in position or the position at 1 second, 2 seconds, and 3 seconds. That's why we have subscripts 1, 2, and 3 also. And since we are looking for 3 positions, we're going to have the same equation, but the solution would be tatlo. Okay, so the equation that we're going to use is delta y is equal to v naught y times t plus 1/2 gt squared. Why? Why this? Because the final velocity is not mentioned in the given and it is also not in the required. Okay? Let's substitute to get delta y sub 1. That's, syempre, 0 na yung ating v naught y. So, we have na lang substitute g, 9.8 meters per second squared, and then the time, and we will get delta y 1 is negative 4.9 meters. Ang ibig sabihin lang ng negative sign yan, again, the object is going down. The displacement is at the negative direction. Then you substitute again to get delta y sub 2. And again, the answer is negative kasi nga pababa nga siya. And then last solution, to get delta y sub 3, that's negative 44.1 meter. Okay? And the answers would be, ayan, 4.9, 4.9 meters, negative 19.6 meters, and then negative 44.1 meters. Diba ganun lang siya kadali? Ang dali lang niya. Okay, so that's for case number 1, which is dropped. And then the case number 2, excuse me, thrown upward naman. So for the thrown upward, here are the conditions that you should remember. Number 1, hindi na zero ang initial velocity mo dito. The initial velocity has a value and it is positive. O bakit positive? Kasi nga, pataas siya. And then, the final velocity is zero. Because when you throw things upward, momentarily at the highest position, in which you will find the final velocity, the object actually stops. Okay? Kaya zero siya sa tuktok. Pag naghagis ka, bago yun bumaba, mag-stop muna yun siya. Eh bakit positive yung initial velocity? Kasi ang iyong object, hindi naman siya maggalaw unless i-applyan mo siya ng upward force, which gives it an initial velocity, and since it is moving upward, the sign is positive. Another thing, the initial position is still zero, but ito yung pinagkaiba nila. In case number 1, the final position is negative. Here naman, the final position is positive. Okay? Kasi nga, pataas. Next. Here's the example. A person throws a ball upward into the air with an initial velocity of 15 meters per second. Your task is to calculate how high it goes and how long is the ball in the air before it comes back to his hand. So, dalawa. Una, yung how high. Tapos, how long is the ball in the air. So, pag ganyan, baka may sabihin nyo, ay, how long distance din? Hindi. It means time. So, we have the following given, the initial velocity. Sinabi naman dyan, 15 meters per second. And then, since this is thrown upward, we know that the value of the final velocity would be 0. And again, hindi natin kakalimutan, since this is free fall, the acceleration is negative 9.8 meters per second. And we have two things to find out. That's the delta y, kasi how high it goes. It means its displacement, no? And then letter B, the time. How long is the ball in the air before it comes back to his hand? So the equations we're going to use are the following. The delta y is equal to b sub y squared minus b naught y squared all over 2g. Bakit iyan? Kasi as you will notice, nawawala nga yung time. So you will not be able to solve for delta y kasi after mo pang masolve si delta y, tsaka mo lang masosolve si time. Okay? And then, since we already have, for time naman, we could use by minus b naught y. Sorry. All over g. Okay? Galing yan sa, kung babalikan natin, wait lang, ibalik natin para makita. O, hindi na siya mabalik. Balik natin sa equations. Ayan. So, saan nanggaling yung t is equal to Vy plus minus ba yun? Sa G. Sorry, pabalik-balik tayo. No? Ayan, so saan to galing? Galing siya dun sa unang equation natin, which is yung Vy equals V naught Y plus G T. Wherein, we transpose the V naught Y to the other side, kaya negative na siya, no? And then, to get an expression for T, we divide both sides by G. Ayan. So, ito na ang kinalabasan niya. Okay? Since we have Vy, we have V naught Y, and we have G, we would be able to get the time. Pwede nga rin na you get the time first, di ba? Tapos, you use an equation for delta y involving time. Pwedeng ganun. Pero, since pwede naman na we could get delta y without the time, we could follow this and solve according to how they are mentioned in the problem. Next, let's have the solution. For letter A, that's delta y. You substitute the final velocity, then the initial velocity, and then 2 times g. And you will get positive 11.5 meters. And then for letter B, as you will notice, after the substitution, we get a specific answer, but there is a very final answer that is 3.06 seconds. Bakit siya T times 2? Because the question ask you how long is the ball in the air before it comes back to his hand. This first time that you have computed, that's just the time for the ball to go up. Paano mo malalaman kung ano yung total time para makabalik siya? Siyempre, the same kung gaano siya katagal umakyat, ganun din siya katagal bababa. So you just have to double the time you will be able to compute to find the final answer. Ito, you double lang the time that you compute if it is asking dun sa pag-come back. Okay? Kasi bumalik siya. But if the problem asks you, halimbawa, how long is the ball before it reaches the highest position? Kapag ganun, you don't need to multiply by 2 the time that you have computed. Okay? So the final answers are the delta y is equal to 11.5 meters and then the time is equal to 3.06 seconds. Okay, so here sa letter B, obviously, this one is also an example of analyzing whether we have to solve for one quantity first before coming up with the final answer. So, hindi ibig sabihin na, ito yung equation, plug in ka na lang ng plug in, and you won't understand or analyze the problem. You need to analyze. Again, for case number 2, thrown upward, if the problem is asking you how long it takes for the ball to come back to its original position, you have to double the time. On the other hand, if the problem only asks you how long does it take for the ball to reach its highest position, you don't need to multiply by 2. Diba? Ganun siya. Thank you for listening to the lecture about free fall. Up next is the lecture about projectile motion.